recorded. So let's see. So we need to write down the conditions where we can do the LU, and the condition is the A matrix is with all the leading principles of the matrix are all non-singular, and this is very important. This one. Requirements for the matrix to have the LU factorization, and for the Cholesky factorization theorems, and you need to say that the A matrix should be symmetric of the definite matrix, and then the unique. So the factorizations are unique, and then this is also very important. Unique, and then this factorization is unique. And for the C questions. The three questions, I would give you the factorizations of the A, as putting the A into the D, LU, the diagonal matrix, and then strictly lower left, and then strictly upper matrix. And I will give you this. I will give you the stripping of the A into the D plus L plus U. And your task is to write down the matrix format for the Jacobi's methods, Gaussian-Seidel methods, and I know the SLR methods to memorize, but that's all part of the exam. And I will only ask you to memorize all these things, and then I will not. I'm not going to ask you other things to write down in the first questions. That one is coincides with this one, but I want you to memorize this one because it's hard to decide the Gaussian animations with road exchange. So this one is coincide with that one, but this one is more mathematical way to judge whether we can use the LU factorization. To do it? Yeah. Yes, the corollary, right? You're mentioning the corollary, but you're mentioning the corollary. So for that one, are you mentioning the LU factorization or collective? The LU factorization one. For that one, it's like just two special situations. This situation. This is the general situation, and then corollary, it only gives you two specific situations. Yeah, so the ones I want you to memorize is just the things happen appear here. And then you just need to take this away and then memorize it before the exam. And this is exactly the same things appear on your exam. And memorize it, and that's it. And I will not ask you other questions, and then this is the standard solution. Yeah, memorize it. And memorize each aspect, each term here, and that's it. And let's say the second thing is Gaussian animations, and I'm not going to. So let's see. Let's take a look at the examples too. So how many of you think you know, and then you know how to do the Gaussian animations very quickly, and then you don't need to take the time to think what is Gaussian animations. You need to take the time to think about You don't need to do it, right? Okay, I know a lot of you learned this in the linear algebra class, so I'm going to skip this calculation, the second example, and then I'm going to the third example, and then I know there are a bunch of people get some points off from your homework, so I'm going to talk about this example. And this is something similar to your homework, and I'm going to write down the solution here instead of the typing one, because the typing one is well typing, but it's not the things you would write on the exam. There are too many words on that one, on the type question solutions. So the question here we have, the questions we have here is the 2x1 minus the 6 alpha x2 and equals to the 3 and 3 alpha minus x2 and then equals to 3 over 2, and it's asking you when is the alpha, what is the alpha value with no solution, and then alpha values with a lot of solution, infinite solution. Infinite solution. And if it has a unique solution, and then preserve it. And now, one important thing about the no solution, infinite solution, unique solutions we have, we need to determine this matrix. Oh, what's happening? We need to determine this. We need to determine the matrix we have here. The coefficient matrix we have two, negative 6 alpha and 3 alpha and negative 1. And then this is the determinant matrix, determinant matrix of the coefficients. We need to get the determining of it, and then with the no solution and infinite solution part. So this is the question A and B. For this, we require this determinant matrix to be 0. So we save this things for alpha and then get a series of the polynomial here. This means that we have the 2 times negative 1 and then subtract the 6 alpha and then times the 3 alpha, and we got this. We want to solve this equation, and then we got negative 2 and then plus the 18 alpha squared equals to 0, and then we got the 18 alpha squared equals to 2, and we got alpha equals to 1 over 9 square root, and then plus and negative. There are 2 solutions here, and then 1 over 3. And we know that for determinant of the matrix, 0 means no solutions. I'm going to use a shortcut here, solutions or infinite solutions here. And this is the thing. So now you can have the alpha equals to the positive negative 1 over 3, and it means no solutions or infinite solutions, but you need to plug in the alpha values into this system or matrix to see whether it is no solution or infinite solution. So case 1, alpha equals to 1 over 3. And we substitute the 1 over 3 into the system equation, and then we got the first equation is the 2x2 minus 3, and then the second one, there's x1 here, x1 minus x2, and there is equals to 3 over 2 here. So because you can say, okay, because these two equations are essentially the same, and hence infinite solutions. We have infinite solutions. And that's it. This is the case 1, because we have 2 solutions for the determinant, the determinants there. And so we test the first case, and then we also have the negative number. So we are going to check the negative number, case 2, alpha equals to negative 103. And we put in the number there, and then we got the value. It should be 2x1 plus the 2x2 equals to the 3. The things below should be the negative x1 minus the x2, and then equals to 302. And you will see this happening. So this one, if you times this one with the negative 2, and then the left-hand side is the same as the left-hand side here in the equation 1, but on the right-hand side, you will get negative 3. And the right-hand side has the same. One is the negative 3, one is the 3. And then so we can see that these two equations have some conflicts. They contradict with each other. So there are contradictions. Hence, there is no solutions. So because these two equations contradict with each other, and we hence the system has no solution. And you can see this, and I'm not solving the A and B separately, and then I am solving the A and B questions together. And the first thing I did here is to calculate the determinant value, let it to be 0, and then test the case here. And then we have no solution case, infinite solution case, and then here, I have already answered the A and B. Any questions? Any questions before we move on? Move to the question C. And the question C is that let's say we have the unique solutions, and then from the question A, we already know that for alpha doesn't equal to the positive and negative 1/3, we have unique solutions for the system. Solutions for the system, and this is because the determinant does not equal to 0 for the system. And now what we want to do is you can use any methods to solve it. And personally, I would prefer to go to do the row elimination, and that's the Gaussian elimination there. So I'm going to use the Gaussian elimination, and 3 alpha, and then -1, and then 3/2. And the first things I did here is I think there's just one thing I need to do. So I'm going to get this part to be 0, and eliminate this one to be 0. So I'm going to use I'm going to change the row 2, right? The row 2 is substituted by the row 2 and then minus. So how can we compute the ratios? I want to remind you how to compute the ratios. It should be the 3 alpha, the A21, and then divided by the A11, and then that is the 3 alpha divided by 2. 3 alpha divided by 2, and then R1, and then this is the things we want to replace or update the rows. Questions?
Makes sense. Do we need to move this one to and or so that is it out?
Yeah, because there's the things on the letter notes, and then that is just the determinants of the A matrix, and then equal to 0. And then there are two cases, and then so we need to solve it step by step. And then determinant A does not equal 0, and then we have unique solutions. And then, but here you don't need to write the determinant and solve the equations again. And then you can just say it for alpha does not equal these things, and then we have unique solution and solve it. The next thing is we are doing the row changes here, and then the first row doesn't change, so that is 6 alpha, and then -3 here. On the second rows we have 0 here. If you do the rows operation, this one equals to 9 alpha squared, and this is the 3/2 minus the 9 alpha over 2. You have to, okay, this is the desired matrix format, because this part is the one right after triangular part. Now we can solve the system backward. This is just reduction and elimination process, and then we get to this simplified. And so for the second row, and then the last rows we have, from the second rows we have this. From the second row, it implies the x2 equals to the, so on the left-hand side, we have the 3/2, 9 alpha over 2, and then divided by the -1 plus the 9 alpha squared. And you can see that there are a lot of expressions here, and then I hope you can simplify this expressions in your exam. It's better to simplify it than leave it in this way. This way, it's not simple. It's not simple to understand the expression. So you can go ahead and then simplify these expressions, and then after the simplifications, and you would get the x2 equals to, let me see, and then that should be the 3 alpha plus 1, and then you, after doing the simplifications in the expressions. And for the x1, we can solve for the first row, and I get the information from the first row, and we have the x1 equals to the bi, the 3 minus the 6 alpha, and then take the x2, and then divided by 2. And we already get the x2 from these expressions, and then we just need to plug in here to do the calculation. And the x1 is just equals to, up to all the calculation and simplification, and then that should be 3 to 3 alpha plus 1. And these numbers are not important, and then I just want to tell you how to solve it step by step. You need to solve the determinant equals to 0. And then this is case by case, and then in the C questions, and then you need to specify alpha does not equals to that zeros in the determinant, and that is, in this case, is alpha does not equals to a positive and negative 1 or 3, and then you need to specify this. And then solve for the solution. Any questions here? Any questions? If you don't have questions in this one, and then let's go to the fourth question. And the fourth question is a little bit special. And actually, this example will tell you that, okay, let's say this example A equals to the 2, 1, 0, 0, and then -1, 3, 3, 0, 2, -2, and then 1, 4, -2, and then 2, 2, 5. And the first question is asking you whether this matrix is strictly diagonally dominant. And you will see the first row. Okay, let's check the first row. The first row we have this, and then that is the 2,
is bigger than the 1 plus the 0. That is the sum of the absolute value of the other elements in the same row. And then the first row is actually we have the diagonal elements is bigger than the sum of the rest of the elements here. And the first row is okay, but let's see second row. And the second row, the diagonal element is the 3. But what is on the right-hand side? On the right-hand side, we are comparing to the sum of the absolute value of the other elements in the same row, and then that's the -1, and then plus the 3, and then plus the 0, and which is 4. And we have the diagonal element is smaller than the sum of the absolute value here, so which means that this is not diagonally dominant. Not strictly diagonal dominant. And you can just conclude here, and then you don't need to check the third, fourth row. But in the question B, is still ask you to factorize the matrix into LU factorizations, the decompositions. And now let's go back to say some remarks here. And you just, so we just mentioned that there's LU factorization theorem, and then there's a corollary there, right? And then that LU factorization corollary is about strictly diagonal dominant. And then there's another corollary is about the positive, symmetric positive definite, right? But you will see this. In this example 4, we can actually do the LU factorization, but that matrix, the matrix is not strictly diagonal. But that matrix in the example 4 is satisfied as using the matrix symmetric criterion here. They are all the same. So this tells us that the corollary on the translation note is not the general case. There are some special cases there. So go back to the example 4. So what is the example 4? Example 4 here. Although the matrix is not strictly diagonally dominant, and then we can still do the elliptic compensation for this matrix, because it satisfies the general LU factorization theorem. It is not a special case 1, the strictly diagonal dominant one, but it still satisfies the general LU decomposition theorem. So now let's go back to take a look at the calculation on the solutions, the Canvas solutions. It takes like 1 page to do it, through the 2 pages to do this calculations. So what I'm going to do is to simplify it, the writing of the solutions. So what you can do is this: 2, 1, 0, 0, -1, 3, 3. This is the starting point. And -2, 2, 2, 5. And you can write the first round of the Gaussian elimination here. And the first round of the Gaussian elimination is just, you can write all the things in one step. And for the first round calculation, and that is the row 2 would be changed, and then row 3 would be changed. Row 4 is, it also would be updated. And then the row 2 is just the -1 divided by 2. And then that is the row 1. R3, 2 divided by 2, 2. And then row 4 is -2 divided by 2, and then row, this is row 1. Row 1, and then row 1, and this is the things. Now, don't forget what we need to do is also creating one matrix here, and then this is the L matrix. And because we have the 4x4 matrix, we have the 1, and I want to tell you that this LU factorizations, the L represents the lower left triangular. So on the right upper part, it should be zeros. And we need to fill in the lower left triangular part. And now what's happening here? So I'm going to write it in the standard way and then take the ratio out and then fill it in there. So this should be the A21, and then this is A31. You can see A31 and then A41. That's the ratios there. So I'm going to record the values here, and I got this. So the first one, it should be the A21, right? And then it should be 1/2. And then the next one should be the 2/2. And then the precision should be A31. So here it should be the 1. And then the next thing should be the A41. And then that would be the -1. And that's the matrix L, the first column. And then I am going to do the row operation here as I indicate here. And after I do the row operations as indicated, and I got this 2, 1, 0, 0, and I got all the zeros here. And the 0 is the 0. Let me see, am I right? This one? Yep. 0, 0, 7/2. I'm skipping the step-by-step calculation, and then you can do it at home. And then I am just writing the format of the solutions you can write on your solution. This is the simplified way to express the solution. So the first step, the first round calculation, the first round row elimination, and then write down the corresponding value there, the ratios there for the L matrix. And let's do the second round of the row eliminations, and then I'm going to get this to be 0. The things I'm going to do here is the things here. It should be the what I'm going to change is the row 3 and row 4. So the things I'm going to update should be the row 3, and then the row 4. And I'm going to update it, and then the row 3 should be the -3, that is the -3 there, and then divided by the A22, that is the 7/2. Subtract by the row 2, and then the row 4, subtract the coefficients ratio here should be the 3 divided by the 7/2, and then the row 2. And this is the thing, -3 is coming from here, and then divided by the A22, and then this one, because this is the R42, and this should be the 42 position here. So 3 divided by the 7/2, then it's the A22. And now, before we move to the actual row elimination here, the calculation here, I'm going to record all the ratios information in the L matrix. And for this one, it should be the -7/6. So I'm doing it this way, and I'm going to remind you of this. I'm not going to write any plus sign here because it's so easy to get ourselves confused which number should be the ratio. So I'm going to write all the things here to be the subtraction side, and then the things here are the ratios. We have this one are the ratios in the position 3/2, the L32, and then this one it should be the -6/6. -6/7. Okay, and this one should be the we just ignore, we just not looking at this subtraction side. We focus on this one, and then this one should be the 6/7. 6/7. Let me see, and I'm going to just copy them the actual row eliminations result here, and you need to spend the time to do the actual calculations. This one should be the first 2 rows is remain unchanged because we just changed the 3rd row, and then the 4th row, and then we got 0, 0 here, and then this one is a 25/7, 4, and then -4, 7, 5. So we are going to do the last step. So we are going to eliminate this one to the 0. So the last step is just updating the row 4. We just updating the row 4 here. The row 4, and then what is the row 4? The new row 4, it should be, the new row 4, it should be this. The row 4 here, it should be the row 4 subtract the, first, it should be the position is 4/7 divided by the A3. And so we have, well, we should have this. -4/1, and then divided by the 25/1, and then row 3, and then use this results to replace the row 4, and then we have, and now we are recording the last information in the L matrix, and then that should be this number. And this number should be the -4/25, -4/25. You are going to perform the actual row calculation computation, and you would get this at the end. Let me see. You would get this at the end. I'm going to copy the result here. The first 3 rows would not change in this last row operation, and then the last rows would become 2, 1, 4, 1, and then 25. Then now, from the knowledge we learned from the class, this is our U matrix, this is our L matrix, and you need to summarize this in the end, at the end. So we would say, okay. So I need to summarize this. I got it. And there's one question. A equals to LU, and then where the L equals to 1, 0, 0, 0, -1/2, 1, -1, 1, 0, 0, 1, 0, 1, and the number here is -6/1, 6/1, and -4/2 over 25. Also, you need to specify your U matrix here, and you just need to copy the things again and to summarize your final solutions. 0, 0, 0, 1, 4, 1, and then 25. Questions? Just like put it there. The things I write down here. Where we need to. You don't need to. You don't need to do the things as the solutions on the cameras. You just need to do the things as I. That's why I'm using hand. In the class. Doing the checking. I just asked you to do the error factorization. You don't need to check whether it is whether the LU factorization can be done for this special matrix. That's a lot of work, so I'm not going to ask you to do that. But actually, in the collective composition question, I'm asking you to check whether the A matrix is positive definite. So let's go to the question 5. Question 5. There are 2 methods to do it. So I want to mention again, I'm using the handwritten solution here because this is the way you can write your solutions on the Excel. You don't need to follow the while typing notes on the what to do this. But I think most of you know how to do the calculation. So there's one more question in the 4. Wow, that's a lot of work. So maybe just 5 questions on your final exam. five computations. That's a lot of work. I know. Let's see. So there's one more question in one small question in the LU factorization. It's equal to V. So we need to solve because we have the LU factorization here, LUX equals to V. And let's say, okay, let the UX equals to Y. And then we also have LY equals to B. And we want to solve this, and we solve for the Y first, and then solve the X next. And for the LY equals to B, and actually I don't want to solve it in the class. And let's see. It's easy to compute it. So for the L, it should be the L 0, 0, 0, negative 1/2, 1, 0, 0, 1, negative 6, 1, 1, 0, negative 1, 6, 1, negative 4, 25, 1, and then you have the Y equals to 1, Y2, Y3, Y4. This is your Y vector. This is the Y vector. And we let it to be equals to the B vector, 1, 2, 3, and 4. And for the first step, and then we are going to use the forward process because it is a lower left triangular. And then it's easy to see from the first row, the row 1, and then we got the Y1 is just equals to 1. And then for the row 2, we got the number. So we got negative 1/2 Y1, and then you press the Y2, and then it equals to 2, and then we got the Y2, it should be equals to 2, plus the 1/2, and then it should be the 2/5, and so on and so forth. I'm not going to perform all the calculations here. This is just a forward process. And then you will get the Y3 value and then Y4 value. And the next step is going to do the backward process. It takes like 20 minutes to finish this one. It's horrible, I know. So there will be just like 5 questions, computation questions. I'm happy to know this before I'm going to compose the final exam. Let's see. What's the U matrix? The U is the 2, 1, 0, 0, 0, 7/2, and then 3, 0, 0, 0, 25, 7, 4. My writing is going crazy. And now this one, you need to have the X1, X2, and then X3, X4 on the left-hand side. And this is your right-hand side here, Y1, Y2, and then Y3, and then Y4. And then from the first step, and then you already know the Y1, Y2, Y3, Y4 value. And this is already known. And then you will follow the backward. Oh, what a message. And you are going to follow the backward process with so for the X4 and the X3 and the X2 and X1 one by one. And that's the backward process. I'm not going to calculate it in the class. It would take like 5 more minutes to calculate or 10 more minutes. I have to admit that this question takes a lot of time. But if you get yourself familiar with this, and then you will get a full voice. The process is easy, but it takes time. It only takes time. The 5 question is the positive definite, and then this one should be a little bit technical if you haven't done the calculus linear algebra class, or you just done the linear algebra class in this semester, and then it could be a little bit technical because you need to be familiar with the method below. So the method 1, so I'm going to answer the question A first, and then whether it is positive definite. And the method 1 is to check eigenvalues of A, and then check the eigenvalues of A. If all the eigenvalues of A are positive. And I would not suggest to do this because I hate to calculate the eigenvalues. You can do this. Let's go to take a look at the eigenvalues we have in this example, and then we are going to get this is the characteristic polynomial. Is the determinant of the A subtracted lambda I. I represent the identity matrix. So which means that we are going to get this determinant for subtracted lambda, and then 3 subtracted lambda, 2 subtracted lambda, and then all the things outside the diagonal are the same. And then I'm going to take this one, -3, 1, and then 0. And I let this one to be 0. And I'm going to skip to the determinant expansion here. You need to do the actual calculation, or you can use your calculator if your calculator has this feature, and then you can use your calculator to calculate the eigenvalues. I'm not sure whether your calculators are able to calculate the matrix eigenvalue, but if it gives you so if you want to show this lambda, the characteristic polynomial, and then equals to 0, and then we got the lambda 1 is 4.879 something, and then the lambda 2 is approximately, also this one is the 2652, lambda 3 is the 14679. So that's why I don't want to recommend you use this method if your calculators cannot calculate the eigenvalues. So all eigenvalues are positive, hence A is positive definite. This is the first method, but I don't recommend this methods because you need to solve the polynomials. And so let's go to the method 2. The first one is to check whether all the eigenvalues are positive, and then you need to solve the characteristic polynomials, the series for the characteristics polynomials. And then the method 2 is all the leading principal matrix, the determinant, or the determinant. It should be the order determinant of the order determinant or the determinants of the leading principal matrix are positive. And this one is easy to calculate. And for example, so the first one, I'm going to check the A1, the left, upper left 1 by 1 matrix, and then that is just equals to the determinant of the 4. And then it equals to 4, and then this is positive. And then determinant of the A2, and then that is the left. So this is the left square part here by 2 matrix. And then I'm going to calculate the determinant. And for this one, the determinant, it should be wow, this is only the five questions, the 5th questions. For -1, -1, 3. And then if I calculate this one, and then it should be the Z11, and then this one is positive. And then the third one, it should be the A3, and then that is the whole matrix. And this one, if you know how to calculate the determinant, you can use your calculator to calculate it. And then this one is also a positive number. And then you can say, because, so we can conclude that. So you can just say we can conclude A is positive definite. And for this one, and then you can just stop here. And then this is the A question. And then for the B questions, we are going to calculate the scholastic factorization. And I have shown you 2 methods on the lecture, on the solutions posted on the Canvas. But I still recommend you to do that. I still recommend you use the method 2, not the method 1. The method 1 requires you to memorize the formula. And it's so easy for you to get the index wrong. So I'm not going to recommend you to do that, the method 1. And then for the method 2, I'm not going to write that one on the handwritten one, because it would be the same as the printed one. The printed one here, I would only recommend you can use the method 1, of course, but I would recommend you to do the method 2. That is this is not updated, but I would post an updated solutions to the Canvas, and it should be using the A matrix. It's the same as what we mentioned in the lecture notes. We are going to write down the B components, and then do the matrix multiplication, and then compare it with the A matrix, the actual A matrix instance. So for the B11, B12, B21, B31, B3, all the information in the B, and that's it. And then for the 6, the question 6 here, I'm going to ask you to find out the L2 norm, L infinity norm here, and then you just need to know the definitions of the L2 norm and the L infinity norm. You don't need to write down the definitions, but you don't need to write down the definition. You just need to calculate it. And I write down here because I want to remind you of the definitions. And then you can just write down the calculations here. Okay? You don't need to write down the definitions as I did there. And then I just want to remind you of the knowledge you learned. And then for the L infinity norm, it's just the maximum absolute row sum. So I take the sum of each row, this is first row, second row, and then the third row, and then I take the maximum, and then that is the A infinity norm. And for this one, you can take a look at the solution. I check different properties. And that is the definitions here, and the norm, the vector norm. We require the non-negativity, positive definiteness, homogeneity, and the triangle inequality. Then we check these properties one by one. But in your written solutions, you don't need to write down the definitions first. You can just go ahead. You can just go ahead to check all the properties here, and then one by one, and then the first property, second property, third property, fourth property. You can just write down this part on your solutions. You don't need to write down the definitions first. And for the B And then I have already mentioned in the class, and then the L1 norm of the matrix, it should be the maximum absolute column sum, because you can see that 1 is vertical, and this is the way you memorize the norm. And this is the sum of the first column, and then this is the sum of the second column, the absolute value. And this is the third column, and then we compare it, and then it's the maximum, and that's the 5. And this is the seven questions, and then I just have mentioned that which part you need to write down on the paper, and which part is not on the paper. So the definitions you can just get it, and then this is something I just want to remind you of in the printed solutions on the tablets, and then you don't need to write down the definitions on your solutions as well. You just need to calculate it. And this is the 6 questions, and then let's see 7 questions, and let's see the 8 questions. For the 8 question, let's see. I will only ask you to perform in the actual exam. I will only ask you to do either the Jacobi method or either the Gaussian-Seidel method. I will not ask you to do both, because it takes a lot of time, I know. And so what you need to do is to write down exactly what we have on the printed solution here, and the Jacobi's solution, Jacobi's methods is updating formula here. So on the right-hand side, all the things are on the K set, and then on the left-hand side is the K plus 1 set. And then I'm going to follow this using this updating group here to perform the iteration 1 and the iteration 2. And some students ask me, so for the iteration 1, what do we get? So from the iteration 1, we just get the x1 vector. And so because we're starting from the x0 vector and then using the x vector, we get the x1. And this is the final results from the iterations 1. And then from the iteration 2, we get the x2 vector. So it's also better to write down the vector format, rather than just writing the component and then stop here. And then if you stop here, it's okay. I'll give you the points, but it's better to write down the vector format at the end. And for the B questions, and then this is the Gaussian-Seidel method, and then you also need to write down the Gaussian-Seidel method updating matrix for the equations here, the updating rules here, and you need to pay attention to the superscript here. For the 1, and then it should be the K plus 1, and then after the 1 should be the K. So before the 2, and it should be the K plus 1. After the 2, it should be the K. And this would be the Gaussian-Seidel method, and then we use this route to update, do the iterations for those. And that's the thing. I will only choose 1 method out of these 3 to ask you to perform the iterations, because it takes time. So it's either Jacobi, it's either the Gaussian-Seidel, or it's either the SOR methods. And then the SOR methods, once again, you need to write down the questions here. So what I am going to recommend you to do for the SOR methods is actually memorizing the general formula on the lecture notes. That one is hard to memorize it. That one is hard to solving the x1, x2, x3, and then changing the right-hand side superscript there. So I'm actually recommending you to memorize the general formula. That general formula for the different situation, the different system of the equations, and then perform the iterations here. And let me see. So one more thing I want to talk about is the 11 questions. This 11 questions is asking you to show that the Jacobi's methods for the linear system to converge. And then for this one, you actually need to compute. So this is something related to the question 1. First, you need to calculate the actual TJ matrix, the iterations matrix here. write down the formula, right? That is the negative inverse L per Q. And for this question, you actually need to do the actual calculations. So what I'm going to do here is to do the actual calculation, and then this is my D, the diagonals of the matrix A in this system of the linear equation. And this is the L plus U in this linear system of equations. If you go back to what we have here, you will see this matrix is with the coefficients 1, 2, negative 2, 1, 1, 1, and then 2, 2, 1, right? And you can see the diagonal is just 1, 1, 1. And then the L matrix plus the U is what we have here. Is the L plus U here. And then also don't forget the negative sign in front of it. And you are going to do the matrix multiplication, and then it you need to get the inverse of this D matrix. It's just the reciprocals of each element, and we are happy to see the reciprocal of the one. This just one itself is the identity matrix, and then times this one. Let me see. There is something typo here. Yeah, there's one typo here. It should be there's a negative sign here, and the other thing is correct. And this is the final TJ matrix. It's the iteration matrix for the Jacobi method. And once you get the iterations matrix, and don't forget that we have a 3 ranks in the general iterations method, right? And it says that the iterations method converge if and only if the spectrum radius of that iterations matrix is smaller than 1. So the next thing we are going to check is the spectrum radius of this iteration matrix is smaller than 1. So first, you need to calculate the spectrum radius. What does it mean by the spectrum radius? Spectrum radius, don't forget that the definition of spectrum radius, this is the matrix, and then it should be the measurement of the eigenvalues. So I'm sorry, you need to calculate the eigenvalues again. It takes time, but this question is super easy. And this is the characteristic polynomial, and then you need to get the characteristic polynomial. Then so for the zeros of this characteristic polynomial, and if you go to standard determinant here, and then you will get this is the characteristic polynomial, and then negative is 0. And we find out that we have 3 eigenvalues, and then or 1 eigenvalue, but they are the same. And repeated 3 times. And then this is number 1, number 2, number 3 are all equal to 0. And now, so by the definition of the spectrum radius, and then we take the measurement per moment, and then it equals to 0, and then it is smaller than 1. And now we can conclude that, okay, the spectrum radius of this iteration matrix is smaller than 1. And it means that the Jacobi's method is converging for this system of equations. So this is the question here, right? And for the question 10. But if the question is asking for the Gaussian cycle method, and then what should you do? You would do this. If the question is asking you if the Gaussian cycle method converge for this system of the linear equations, and then what should you do? You should go to the calculation here for the actual system of linear equations. You just need to do you need to get the iterations matrix. This structure doesn't play a part here. So you don't need to calculate this one. You need to calculate this one. They get the number in the matrix, and then get the spectrum radius, and then to check if it is smaller than 1. And that's the thing for the last questions. But I would not ask you about whether the SOR method, you could say, So that's all the things. And then any questions about the take-home homework? Oh, no, take-home final exam. It takes like 10 points. If you want to ask a question, ask the questions. Or you haven't seen it, you haven't read it yet. Okay, okay, good news. That is super difficult. So try to take a look at the question as soon as possible. And then find a classmate to discuss the questions. Yeah, this is my suggestions. Yeah, any other questions? It's super difficult. It takes like 1 hour, 2 hours to write the hint. I would just give you the hint, or maybe say, if you say, am I right here? And then I will not answer this question. But if you say, do we need any other tool to prove these questions? And then maybe I will ask you answer the question. Because this is final exam, it's not a homework, and then I will not be so generous as before in the office hour. Yeah. And I will not check your answer for this one. This one? This one? Wow, this one, interesting questions. And have you taken the linear algebra class? So, here's one way you can use your calculator. This is the first way. And the second way, and then I would like to remind you of it. So let's say there is this one, if this matrix is a workable, let's say 4, 5, 6, 7, 8, 9. And I would like to remind you there's one method to take your matrix, and the identity matrix on the right hand side. Do you remember that? 1, 1, 1. There's 0, 0, 0, 0. And then now you are doing the same thing that you did in the Gaussian elimination system. To the row operations. This is your A matrix line. You write it in this way, A and then I. And then the things you are going to perform the row eliminations or the row multiplication, and you will change this to I, the left-hand side change to I, and then on the right-hand side, it would be the A inverse. Do you remember this? This is something about the linear algebra class that you will have your calculator. Any other questions? Of course, you can do it.
But like what, like simpler ones?
You are allowed to do it. Yeah, because you have the calculator, and why not? Yeah, and this is not the linear algebra class. This is just numerical methods, and then I want you to know the algorithm, and then I want you to perform the algorithms, not the linear algebra class. I don't care whether you do it by hand for the matrix multiplications or whether you do it with the calculators. And that's all the things. And let's see, it's already 12:11, and then if you have some private you want some private conversations with me, and then you can come with you. Some private questions. Can I get some bonus points? And then maybe. And then most of the time the answer is no, because I will not give bonus points to a special person. If I want to give the bonus point, and then it would be for all the people here. Bonus point, the extra assignment summary. Do you turn on it? Turn on? Got it. And then I will just see you next week. in the final exam or in my office hour today. Let me